Hi guys, welcome to this video, and in this video I want to talk about pair of straight lines. So let me write it down. Okay, pair of straight lines. Okay, first of all, what do we mean by a pair of straight lines? So in order to demonstrate this, I have to draw the coordinate plane, so bear with me for just 1 minute here. So let's say that this is the coordinate origin. I will call this as O, and then I have a straight y-axis. This is my y-axis and this is my x-axis. Now I want to draw two lines such that both of these lines pass through the coordinate origin and they can have different slopes. So let's draw the first line. So let's say this is my first line, and it has, let's say that this is L2 and it has slope M2, and let's say that my second line looks something like this. So this should be actually, so let's say that this is L2, this is my second line. I actually drew the second line first, and let's say my first line looks something like this. This is L1 and it has slope M1, right? Okay, and slopes are just arbitrary, they can take pretty much any value, but the only condition is that both of these lines should pass through the coordinate origin, and if they do, what I want to prove to you or show to you is that they can be represented by a general form, which is ax square plus 2hxy plus by square is equal to 0. I want to show you this is true if this is the case. So let's actually do this. Now obviously you might be knowing the y-intercept form or the slope-intercept form, which is y is equal to mx plus b. If I consider the first line and I write that line in the slope-intercept form, so it's going to be equal to y minus m1x is equal to 0, right? Hopefully that makes sense. It's nothing new here. And similarly I can do that for the second line. It's going to be equal to y minus m2x is equal to 0. Now how can I make the equation of a pair of straight line? How can I represent these two individual lines in a collective way, such that if I take any general point in either of the lines, that satisfies the general equation of that line? So what do I mean by that? So I want to construct a new equation such that it is true for any general point if it sits either on this L1 or L2, and it is not true for any other point. Like if I take this point which is not a part of which doesn't belong to L1 or L2, it's not going to satisfy the equation that I want to construct. So in order to do that, well, we can just multiply. Let's call this equation 1 and let's call this equation 2. We can just multiply 1 and 2, and I'll show you why this is true in a minute. So first of all, let me write it down. Y minus m1x multiplied by y minus m2x is equal to 0, of course. Now this is essentially an equation which represents a pair of straight line, and I'll show you why this is true. So first of all, let me consider any point on L2. So let's say that I consider any general point on L2. So let's say that this is x comma y, any general point on L2. When I input that point into this equation, which I'll call as 3, when I input that point into the third equation, then this will become 0 and this will be a non-zero number, but it doesn't matter, because if I multiply something by 0, the answer is always going to be 0. So what that means is that any point on L2 satisfies this general equation, which represents a pair of straight line, which we are just proving. And let's say that we have any general point that sits on L1 and let's say that this is also x comma y. When we input that point into this equation, this term now is going to be 0 and this term is going to be non-zero, but it doesn't matter because when I multiply 0 by a non-zero number, it's going to be 0, right? And now if you consider any other point like this or this, and let's say this is also x comma y, if you input that point into this equation, what you'll see is that this is a non-zero term. Similarly, this is a non-zero term. When you multiply two non-zero terms, you are obviously not going to get 0, and what that means is that this is not going to be part of either of these lines. So what we have just proven is that this indeed represents the locus of all the points that sits either on L1 or L2, or in other words, this represents the equation of pair of straight lines. Hopefully that makes sense. Now what I want to do is, first of all, I want to write this in an expanded form. So when you multiply all these terms, you will get 4 terms, and then first of all let me write the terms: y square minus xy m1 plus m2 plus m1 m2 x square is equal to 0. So when you multiply, when you open this brackets, you will get 4 terms, and then since minus xy is common in 2 terms, you can just factorize that, and then you'll get just 3 terms, right? So nothing fancy here. Now I want to compare this equation. First of all, let me label this equation as let's say 4. I want to compare equation number 4 with the general equation. Let's say that this is equation number 5. I want to compare 4 with 5, but in order to do that, I have to first of all remove the coefficient of x square, not x square, y square, because in this equation y square is 1, but in this equation it's b. So let's do that. Let's divide equation 5, both sides of equation 5 by b. So it's going to be a upon b, 2hxy upon b, and then plus y square is equal to 0. Now let's see if we can do that. Well, the coefficient of y square in both these equations are 1, and then we have minus xy term here. You can just ignore minus because it's just a constant. We have a xy term here, we have a xy term here, we have a x square term here, and we have x square term here with a constant sitting below it, of course. Now if you compare these two equations, what you will get is m1 plus m2 minus of m1 plus m2 actually is equal to 2h, right? And then 2h upon b, because we also have a b, and then just multiply both sides by -1. It's just going to be equal to minus 2h upon b. And similarly, if you do that for the x square term, what you will get is m1 m2 is equal to a upon b. So how we got these results? Well, we just compared, we just pattern matched equation 4 with the general equation number 5. And how can we do, and why can we do that? Well, this was the starting equation. What I told you earlier is that this is true, and we just proved that it's true here, right? We got this form which was similar to this form. Then obviously if this is true, then we could just like compare, pattern match it, and we just got the relations of m1 m2, the slope in terms of the coefficients of this equation. And we'll see why this is helpful. So we'll see why this is helpful in a minute. So let me move to the next slide, next screen. Okay, so now let me draw this again, the diagram. Oops, I want to draw that coordinate plane again. This is y-axis, this is my x-axis, this is my x-axis, this is my y-axis, this is my origin. And let's say this is the first line L1 with slope m1, and this is the, let's say, the second line L2 with slope m2. Now you see this angle that is formed between these two lines. I want to calculate this angle. So how can I do that? Well, we know from basic trigonometry that tan theta is equal to m1 minus m2 and then 1 plus m1 m2, right? This is just from basic trigonometry. You can just revise your formula if you are wondering how I got this. And I can also write this like this. So since we don't have m1 minus m2, I can represent this in a form which has all the terms in terms of m1 plus m2 and m1 m2, so multiplication terms and the addition terms. And the reason I am doing that is because I don't actually have m1 minus m2. So if you think about this, we can write the we can represent the numerator like this. It's going to be m1 plus m2 whole square, so m2 whole square minus 4 m1 m2. And again, the reason I am doing this is because I only have m1 plus m2. If you refer to your previous slide, my previous slide, where I just pattern matched the terms, compared the terms, I got m1 plus m2 and I got m1 m2, right? And then this is going to be equal to m1 m2. Now all my terms are in terms of m1 plus m2 or m1 m2, so I can definitely calculate the angle of the straight lines, which is theta. So this is going to be equal to, first of all, let me write relations again here. So we got that m1 plus m2 was equal to minus 2h upon b, right? And m1 multiplied by m2 was equal to a upon b. Just input or substitute these this set of data into this equation, and what we'll get is 4h square upon b square minus 4 a upon b, and this is all under the radical sign, divided by 1 plus m1 m2, and m1 m2 is just a upon b. Now if we take b common, I mean if we just take the LCM here, so it's going to be a plus b divided by b. And here if I multiply this term by b, if I multiply numerator and denominator by b, it's going to be b square, and the numerator is going to be 4ab. Now what I can do is I can I can take the b square out of the radical sign. It's going to be equal to tan theta is equal to, so I can also take out the 4 since it's common in both these terms. Is going to be equal to 2 upon b under root of h square minus ab, right, divided by a plus b, and then a plus b divided by b. But since we have b here and we have b here, we can just cancel that. So what we are left with is, let me make some room here. So what we are left with is tan theta is equal to 2 divided by a plus b under root of h square minus ab. So tan theta is equal to this. But what about theta? Well, theta is just equal to the inverse tangent of, or tan inverse of, 2 divided by a plus b, and we also have here the term h square minus ab. So hopefully that made sense to you, and in the next video I'm going to show you some examples. And what I want to do in this video was just to calculate the angle between the two straight lines that are passing through the coordinate origin. And I wanted to show you the general form of the pair of straight lines, which was something like this: ax square plus 2hxy plus y square is equal to 0. So hopefully this makes sense to you. And so what I want to I want you to do is just memorize this equation, just memorize what we have in the next slide, just memorize this and you are good to go. So you just need to memorize these two formulae, and then we can just derive anything else, or we can just solve questions from it. So thanks for watching this video.